Yeah, I hope you're not asleep yet. Even then, I will wake you up, hopefully. So since only you have been to the speech yesterday, I have to give some upfront information about who Juniper is and what we're doing, so that you are in the right picture of what it is all about. I'm taking care of the region CEE, so I'm working with partners, working with customers, and holding presentations, as you can see. So first of all, and this is not because I'm a historic researcher trying to tell you what we all did in the past, it's just a single, let's say, explanation about what we are and what kind of company we are. This is what I'm giving you. So as you can see, we've actually been founded in 1996, and our founder, who is still our CTO, his idea at this time was, and this is all about the company, how it is still shaped today, his idea was to build the fastest possible systems that exist on the market, because his anticipation in 1995, before he founded the company, was that in the future there might be a lot of service providers and other companies and enterprises that require a lot of bandwidth and performance. So that was actually the background of his development of the first router, which was 4 times smaller than the at this time existing router with 5 times the performance. So if you think about Juniper, it's always about speed, it's about reliability, and it's about security. Those are, let's say, the 3 cornerstones of our R&D development department. That's what they have in mind when they are developing a solution. And this is still the same today. Most of the enterprise customers, or a lot of them, don't know us that well as the SPs, because our routers, our switches and firewalls, they were mainly produced for SP sector, which means customers which expect a high reliability, high performance, fail over in milliseconds without losing packets. That's where our systems are coming from. And that's the same, those are the same systems that we are shipping to enterprise customers, which should be a benefit for them as well. So that's just the historic background. There's one more slide about Juniper and what is different between Juniper and all the other vendors. It's not just another firewall, it's not just another switch or another router. And why is it not just another box that we are selling? It's because we are producing the whole landscape or the whole solution from scratch. So if you look at silicon, that's just simply our chipsets that we are developing. So for the high performance stuff, we are not using any Broadcom or any legacy generic chipsets like others do in their systems. We're producing our own chipsets. And if you're a little bit, let's say, technically oriented, then you know that if the chipset does not support a specific functionality, you will never enable it by software. So that's how we are designing our systems. And there is a good example of how this system is different from others. So British Telecom, for example, they're using in their lab a router from 10 years ago, which is running the same operating system or the latest operating system that is available today. That means there is a chipset on it that supports functionalities that we are actually developing 10 years before, which means they are using IPv6, for example, without having had the, let's say, the focus on inventing it 10 years afterwards. So the chipset is really limiting the functionality. That's why we believe our own chipset is necessary to be developed, because then we can actually increase performance, reliability, and make sure the investment is actually protected for the customer. On top of that, certainly, we're producing our own chassis, our own backplanes, our own line cards. Not all of them, certainly. Some of them are industry standard, but a lot of them are produced by us, as well as the Junos operating system. The operating system that we've been using on a BSD basis since 1996 is still the same. It runs on all our system, or let's say on 90% of our system. So if you look at that, that's our portfolio. And if you look at security switches and routers, those are the ones that are all running the same operating system. Why is that important, or why does it make sense? It makes sense because on the firewall, you also have switch ports. On a router, you might have security functionality, or on a switch, you might have functionality from layer 3, which is routing functionality. If you run the same operating system on the same hardware, it's just in terms of chipset and interfaces the difference, but the rest is just simply the same. So if you configure, let's say, a static or dynamic route on a router or on a firewall, it's just simply the same command, the same functionality, the same system in the end. It's just the hardware that actually distinguishes all of them from each other. If you look at, for example, I don't know, let's pick one, the biggest, Cisco. They are running on a 3750 switch, on a 4500 switch, 6500 switch, 3 different operating systems. Even though they are all called iOS, it's totally different operating systems. So you know what that means in terms of development, administration, management, a lot of overhead that is not necessary. So that's what we believe in. That's the difference between Juniper and all the others. And that's why I said in the beginning, it's not just another box. So looking at the design scenario, this is also something that we use to distinguish ourselves and our customer networks from others. We try to make it simpler. That's very simple, or very frankly speaking, the idea that we are having of the networks, make them more reliable, make them faster, and make them simpler. So what's the difference, or how do we understand the network? It's not a secret, let's say, that networks nowadays are working not on this basis of server and client communication. It's not 95% of the traffic forwarded to a client, not at all. The system or the server networks, the database networks, they are running on an either SOA or similar kind of structure, which means 70% or even more of the whole data traffic is actually circling inside the data center. So that's how it works, and that's why you need a lot of performance, as we saw before with NetApp as well. You need a lot of performance inside the data center between the servers and the applications that are running there, not on the client. So what does it mean? If we look at that, you have a server on the left, or yeah, it's on the left, sending a packet to the server on the right, or application. So that's how it works. That's a classic infrastructure with access, aggregation, and core layer. So, or access distribution core layer, however you want to call it. But it's a three-tier architecture. So you have to think how long it takes to send from the left server to the right server a packet over 3 different hops. You can imagine there is a lot of hops, a lot of latency, and a lot of, let's say, single sources of failure that can actually occur in the path of the packet. So that's how classical networks are actually designed today, because most of the other vendors have this kind of structure. So that's a classical network drawing, as you will see it with Cisco, with HP, with Alcatel, whomever you want to take with Extreme. They're pretty much doing all the same. It's access distribution core layer. A lot of failures that can occur in this path, and a lot of actually speed that is taken away just because of the single hops that you're having. So too many devices, operating systems, high latency, whatever you want to put there. It's just cumbersome. So how do we do it? It's very simple. We have 2 layers. We have a core layer, we do have an access layer. So what's the difference? Well, it's 1 layer less, so you have to buy less equipment. What's the benefit? On the access layer, we do have all the intelligence. So currently, especially if you look at the data center and all the fabric path switches that are being released, those are switches actually with nearly no intelligence. They are just there to forward traffic. So looking at the access layer that we are having out here, saying it's probably a 4200 switch or a 3300 or a 4500 from Juniper, those switches are not only dummy or dumb layer 2 switches, they are full functional layer 3 switches. This layer 3 functionality is included into the switch with the base license. 90% of all the functionality, except for those which are interesting for SPs but not for enterprise customers, are included in the base license. So buy another switch from someone else, you never will find that. Maybe on top of that, they give you an additional pricing to include some more layer 3 functionalities. But here you have the full layer 3 functionality, which means there is no need for a dumb device that just forwards packets. This is an intelligent device. And more interestingly, if you have a, let's say, performance evaluation between all those different vendors on the layer 2 switches that we're seeing right here, you will see that we are still faster than all the others. So for us, it's not necessary to get rid of all the content in the iOS or in the configuration. It's just simply because we're building our systems differently with other chipsets, with other operating systems, having the same performance in the access layer than others, but with much more intelligence. And that's why we just simply don't need an aggregation or distribution layer. It's just really not necessary for us to have it. On top of that, and that's what actually the speech is a little bit about today, we have a functionality that is called virtual chassis, as you can see. So if you have ever heard of a stack, you can somehow compare it, but you can't. So I'm giving you a little bit of an insight what a virtual chassis is. What you also have to realize, all the devices that you're seeing right here, so be it the switches, be it the core routers, or be it the edge routers, or the internet routers that you have on the MX platform, all of them are running a virtual chassis. A stack is something that you think of if you think of a switch. A virtual chassis is something that you think of either being a router or a multi-layer switch. So for us, it's not only a switching technology or functionality. So certainly lower latency, increased bandwidth, all of this higher reliability or less power, or whatever space, you will find if you use less equipment. Very simple. Sometimes, and this is maybe the only additional info that I have to give you, if you're sending a packet, let's say from pointer, yeah, here. If you're sending a packet from the server on the left to the server on the right over there, you never have to cross the core layer. It's not necessary. So even with all the other infrastructures that you're having, 3-tier architectures, you always have to, in 90%, to go via the core layer. With us, it's not even necessary. It's switch path, line card performance that you're having. Big difference between the others and us. So virtual chassis technology, as I said, it's also something that we use to distinguish ourselves and our technology from others. So what's the advantage of a virtual chassis compared to a stack that you have on the switching side of, let's say, Cisco, HP, Extreme, whatever. Take whomever you want to, they nearly have all the same. So it's a single managed unit. So if you're speaking about a virtual chassis, just imagine you have 10 pieces of 4200 switches from Juniper. This is a single unit that you're actually configuring. You're not configuring 10 different switches. It's a single unit that you configure. You have a single protocol. It's the protocol that we call the virtual control protocol, chassis control protocol. It's what we are using to actually control all the members of the chassis. It's a single image. It's a single config. What does it mean? So imagine you have a stack with some other vendor. You have you have switches, all the same kind, different kind of operating system release versions. What you have to do, you first have to take each single switch, have to upgrade it to the right release, and then you can input him or you can insert him into the stack. With Juniper, it's different. You just input whatever switch you want, and you just get an auto upgrade of your operating system. You don't need to care what is on it currently. You just have to make sure you include it via the single managed unit into your chassis. That's it. Auto upgrade functionality done by the director. So redundancy, there is no single packet drop. If one of the switches in the chassis fails, you don't lose a single packet. You have no single point of failure because all of the 10 different members of the chassis can take over the master or the backup role. And even if the master or the backup fails, in between these 10, they automatically assign another master or backup if necessary. You don't have to do anything to make use of this functionality. So it's totally flexible, however you want to have it. Even then, you might say, I don't want the automatic failover, I don't want the automatic reassignment. Okay, then just configure it statically. We give you the opportunity to do that. Non-stop forwarding is kind of a protocol or functionality that we use, including state tables and kernel synchronization, so you never lose any of the states. So even if a switch fails, you still are forwarding. Even if the master brain, the director fails, let's say, or the master that is holding most of the information, even if this one fails, the packets are still forwarded. You don't lose any single information even if the master fails. No worries. The packets are being forwarded, even if the director or the brain actually dies. So higher performance, as you can imagine. What we are also not really using very often is a spanning tree. So with most of the other vendors, you are actually obliged to use spanning tree. It's kind of an industry standard, but we believe it's not really necessary to have it because spanning tree is just simply blocking 50% of your path. So you have 50% less of the bandwidth that you actually bought. So for us, it's not really a good idea to use spanning tree. It just messes up the whole configuration. If you have ever configured spanning tree or if you have ever used it, you know what I'm talking about. So still, we give you the opportunity to use spanning tree. If you really want to, yes, please use it, but you don't have to. Line card speed, that's what I said about chipsets, about operating system, about the functionalities that we include. We forward at line card speed. Shortest path for all single IPs. We have a full state table, kernel state table, and forwarding and routing table and switching table inside every access switch. That means they know the shortest path. They don't have to go to the distribution or core layer to ask, what's the shortest path to the system? They already know it. 10 units in a single virtual chassis, that's the maximum that we're having right now. I don't know how many you can put in the stack, but that's what we're having. But on top of that, what you have is a cross-platform support. So that means you're not buying only 4200 switches for the same stack or virtual chassis. You're buying, let's say, 4 4200s and another 2 of the 4500s or the 4550s, and you include them in the same virtual chassis. With a stack, this is not possible. With all the other vendors, you have to have the same unit, you have to buy the same unit and put them in the same stack. With us, you can just grow as you go, as we call it. So that's just how you want to increase your network or how your network increases. You might not be able to say upfront 2 years. So you just start, let's say, slowly with 6 units. You increase with bigger or smaller units, however you want to have it. It's just really flexible. We believe this is better than just always buying the same units. Especially after 2 years, if the performance of the units that you bought 2 years ago is maybe not even applicable anymore or not state of the art. Cross data center, what does it mean? You can have a virtual chassis between data centers. So you have a single data center in Budapest and you have another one in, let's say, in Vienna or Budapest or wherever you want to have it, 80 kilometers far apart. You can have a single managed unit virtual chassis between 2 data centers. So you have 5 switches here, 5 switches there. This is a single virtual chassis that you are having. Also I think, flexible. As I said, it's grow as you go, and I will give another example how this works, the grow as you go model. And you have 50% lower power consumption in years of green IT, and everybody is taking care about the operating expenses in terms of energy. This is quite an important approach. So if I, for example, look at the functionality of our QFX data center switch that we're having, the 3500, it consumes 280 watts. If you look at the new Nexus 6K that has just been released, which is actually the same as we are doing in terms of technology, they use 900 watts. This is 4 times the amount of energy that they are using for the same functionality as we are using in our switches, even though they have still limitations that we are actually not having, just as a small comparison of the OpEx that you might want to look at. So who is supporting or which units are supporting virtual chassis? As I said, it's not only a switching functionality, it's both for switches as well as for routers. So if you have your QFX data center switch with fiber channel over Ethernet support and all the other 10 gig, 40 gig, 20 gig, 100 gigabit interfaces, they are supporting virtual chassis, as well as our virtual chassis, our physical chassis switches, the EX8200, 9200, they are supporting it. The lower ones, 3200, 4200, 4500, 4550, you can put them all in a virtual chassis, as well as the MX480, 960, 80, whatever. All the routers, build a virtual chassis, configure them as a single managed unit. So that's just simply how it looks like. I've showed you this before. It's just to illustrate what I just said. Who can you put into the same virtual chassis? Is all of them. On the other hand, so who is using that? That's just a board slide to brag a little bit. Who is actually running with our technology? So those are just 3 of them are the wins of last year. So the new Google Green IT data center is running on our switches, as well as the Apple iTunes Store is also running on this kind of technology, as well as China Mobile chose us, which is the biggest mobile provider in China, over Huawei. Who and why? So yeah, sure, they chose Juniper to have the most performant and redundant network that they can buy. AT&T and Verizon anyway, those are our long-term customers. That's just to tell you how do we work. Those are the customers that we're having from the beginning. Those customers are actually triggering our development. So if they say they need a specific functionality in the next 2, 3, 4, 5 years, this is what we are developing for them. And this is what we are giving to all the other service providers. This is what we are giving to the enterprise customers. So they are really the ones who are shaping the technology, parts of it. Certainly not all of it, but parts of it. But I did not show you this slide to just say, oh, we are the best, we are the fastest, whatever. Not only are 6 of the 7 largest stock exchanges in the world running our systems, as you can probably assume, for them it's microseconds or milliseconds that they are actually looking at in terms of speed and reliability. They can use, lose, or win money in microseconds. So they also are running our systems. But why did I show you this slide? Because I said we're giving the same functionality to the big ones as we're giving to the smallest ones. So if you're an SMB and you want to actually build your data center, you don't know how fast your company will be growing, you have no idea, you have a big plan, you have a super business plan, whatever, you have a good outlook, but you still don't know. So will you go with a 6500 from Cisco to make sure in 2 years when you have extensive growth, you still can use or support all the requirements of your network? Probably you don't even have the money to buy 6400 or 4500. So what would you do? That's a big thought. What would you do with Juniper? That's much easier. You just simply take 2 of the 4500s, and this is your core switch. This is your core layer 2, layer 3 switch. And let's say on the bottom, you either use on the access layer 4200 or 3500 of, 3300 or 200. This is what you can use in the access layer. And that's just your simple data center. And if you grow, if you actually see your business increasing or your network increasing, what do? You just include another 4200s or 4500s or 4550s into your core data center and increase your performance and functionality just by this. So this is also the grow as you go model, as I illustrated before. This is how it works. This protects your investment. This actually makes sure you can grow your business based on the requirements on the increase in your business that you are seeing. It really protects what you're spending on Juniper, on the technology. So from the competitive point of view, I mentioned a lot already. It's just a short wrap-up, let's say. A virtual chassis is not a stack, as you can assume, and as you have probably understood today. Also, if you, for example, have a bigger network, Cisco 6500, for example, with the VSS functionality, which is the, let's say, comparable technology on the big core data center layer, well, but they only can put 2 into a virtual chassis. So what if you have 2 data centers with redundancy inside the data center itself, which are 4 core switches? You will never put them into a VSS because it simply doesn't support it. With Juniper, you can do that. So there might be a few questions that you want to ask if you're investing, if you try to, or if you intend to buy new functionality, a new data center or new switches, whatever, routers. You might want to use some of those questions to ask the other vendors if they support it. So if it is a graceful router engine failover, if it's something that they're supporting, well, just simply ask them. Non-stop routing, non-stop forwarding, functionalities and features that we have built into our system to not lose a single packet. That's functionality that SPs are using today to not lose any of the packets, not even half of it. Management redundancy is also something that you might want to ask them. So if the brain dies, what happens to the network? What happens to the switches? Do they still forward the packets? On the other hand, ask for non-spanning tree redundancy or functionality, something that they support. You probably won't get a good answer to that. If they are supporting mixed platform stacks or chassis, as we call it, probably also don't get an interesting answer to that. If they support a single operating system is also quite an interesting question to them. Just as an example, the ones that I mentioned right here. Below 50 milliseconds failover could be challenging for the others, as well as layer 3 and high availability features included in the base license that you have if you buy our functionality or our switches, is something you might, from an OpEx as well as from a CapEx point of view, be interested in. Not mentioning the hot swappable interfaces that we are supporting. So that's very simple. An introduction on how Juniper works, that's very simple. An introduction of how we think, how our R&D is triggered, and how we want to, let's say, convince customers that there is not only Cisco and a few others that are all using the same chipsets, they own the same functionality. It's not how we work. It's not what we believe in. 1/4 or 25% of our yearly revenue goes into R&D. We're not as much a marketing company as the others because we just believe we invest more into technology, not into marketing slides. So that's simply how our company is shaped. This is the spirit on which Padrip Sindhu, our founder, our current CTO, built this company and is still heading it this way. He's really much a technical guy. That's why he's not the advisory board member or the CEO. He's really the CTO because he wants to really still drive the technology forward and make sure the best is available on the market that we can build. And that's nearly all. So if you have no questions, then... No room for questions? Well, anyway, have hopefully answered everything. So thanks a lot. Have a nice day.